Okay, so they don't really tell us what E and E sub 0 are explicitly, but E means the amount of energy, and then E sub 0, I'm not entirely sure what that stands for, but we can still solve the problem. We have this formula to help us calculate the moment magnitude scale. It sounds like a way of measuring the strength of an earthquake. So one earthquake has a magnitude of 3.9 on the moment magnitude scale. So we plug 3.9 in for M. And then the key here is actually going to be E. They tell us the second earthquake has 650 times as much energy as the first. So we want this is an equation that's talking about the first magnitude, right? Because we plugged in 3.9 from the first magnitude. So let's solve this equation for E. I'm going to multiply both sides by 3 over 2, right, to undo the 2 over 3 on the right side. So if you do that, 3.9 times 3 divided by 2, that gives us 5.85 on the left side. And our goal is to get E by itself, because we have something we can talk about with E, that the energy of the second one is 650 times as much as the first. So let's express how much energy was in the first earthquake. Let's solve for E. And to do that, this is a log base 10. So what you want to do for both sides is have both sides be on top of a power of 10. So I put 5.85 on a power of 10, and I'm going to put log base E over E to the 10th. E sub 0, I should say. So it's a balanced equation because I have 10 to the 5.85 equals 10 to the something. 10 to the log E over E to the 0. Okay, so it's balanced, and the whole reason I did that is because when you have a common log, when you just write log without a base here, it means a log of base 10. So 10 to the power of log base 10, they cancel each other out, and it leaves you with just E over E to the 0. That equals 10 to the 5.85 over here. I don't know if Mobius wants to simplify that. Let's just keep it in exponential form. We've almost completed our goal of getting E by itself. Let's get E to the 0, something that's not defined in the question. Let's get that by itself. Let's get E by itself by multiplying both sides by E to the 0. I shouldn't say to the 0. That makes it sound like an exponent. E sub 0. There. Now we have E by itself. So what we can do with this is the fact that E in the next earthquake, the energy of the next earthquake, so I'm going to put the word next down here. You don't necessarily have to write that, but this is to distinguish it between the E of the first earthquake, the energy of the first earthquake. The energy of the next earthquake in my question is 650 times the energy in the first earthquake, and this is the expression for the energy in the first earthquake. Right, so now if we plug this into the formula, let me get some more room here. The formula is that the magnitude equals 2 over 3 times log E over E sub 0. If we plug this in for E up here and simplify, then we'll be able to solve for the magnitude, because those E sub 0s, those mystery constants that we don't know about, would cancel out. So this is M equals 2 over 3 log, and now our new E needs to go up here because we're trying to figure out how much the magnitude is when the energy is 650 times as much. So I'm plugging in what we just solved for E down there for the next earthquake. 650 E sub 0 10 to the 5.85. That's all over E sub 0. Okay, so these are going to cancel out. E sub 0 and E sub 0. That leaves us with M equals 2 over 3 log 650, there's a decimal in there, 650 times, is that 650 or 6? Yeah, that's 650 times 10 to the 5.85. This is calculator work. You could plug this in your calculator. Let's do, in my Windows calculator, you have to hit log after. If you're using a scientific calculator, you can probably type in log and it opens up a parentheses. But let's do 10 raise that to the 5.85 power. So here's the exponent, 5.85. So that's 10 to the 5.85 power, and multiply that by 650. And now if I press the common log, that gives us our logarithm, and then if I multiply that by 2 and divide it by 3, that takes care of the fraction. So I got 5.7775. Where does it want us to round? Nearest hundredth. So we're going to say 5.78. So the questions in Mobius that have just number answers I'm always thankful for, because we don't have to worry about like typing it in a special way that makes Mobius happy. There we go. So it's a big problem, and you know, if it was me, I probably would have defined what E and E sub 0 are, just so there's no mystery there. But the truth is, you don't need to know what E sub 0 is, because when you solve this, they cancel out.